So kind of similar to when we were graphing polynomial functions, we have a strategy for graphing rational functions. The transformations work great, but sometimes they just don't always come obviously in that form of a transformation. And they might not be able to be one of our basic rational functions. So the first thing we do is we check for symmetry. And again, I really only find it helpful if it's an even function. We can find y-intercepts. We've done that. You just find f of 0. And then we can find x-intercepts. You find x-intercepts by setting the numerator equal to 0, right? Okay, so if the numerator is 0, those will get you your x-intercepts. Vertical asymptotes, those are the zeros of the denominator. So set the denominator equal to 0. And we've done that. Horizontal asymptotes, you go by the degrees of the numerator and the denominator, and you'll have to use that chart, if n is less than m, if n is equal to m, or if n is greater than m. Okay, then you have to find some points. You have to find points in each section. Okay, and you want to know what's happening to the right and left of the vertical asymptotes. Okay, you use all that information to make the graph. So here we have an example, and we'll try to follow this. Is this going to be an even function? No, it's not going to be even and it's not odd. So there's no symmetry. Now you're probably saying, well, how do you know that? So this is odd, but this has an even, it's x to the 0. Okay, so that means it's not going to be symmetric. So it's not even or odd. You could put in f of x. This would change its sign. This would change its sign, but that's not going to be the original function. It's not going to be the opposite of the function. So there's no symmetry. Okay. Let's see. 2. What was this other thing we were supposed to do? Forgot already. The y-intercept. Usually I do the asymptotes first, but it went to be in line with the book. So the y-intercept. So what is f of 0? Well, in our case, it's going to be 2 times 0 minus 1 over 0 minus 1, which is going to be negative 1 over negative 1, which is going to be 1. So that gives you a point 0, 1. Right there. There, we've drawn that point, 0, 1. 3, find the x-intercepts. Well, to find the x-intercepts, you're going to take the numerator and say, when does that equal 0? Well, you add your 1, divide by 2, and you get x equals 1 half. That is another ordered pair. So 1 half comma 0. All right, 1 half comma 0. So right there, that's a point. We know those 2 points. All right, now we want to find probably the vertical asymptotes first. So the vertical asymptotes. Let's see, vertical asymptotes when the denominator equals 0. So x equals 1, that's a vertical asymptote. And what about the horizontal asymptotes? We just have one vertical asymptote. Okay. Horizontal asymptotes. You have to look at the degrees. The degrees are the same. So n equals m this time. And so we're going to have y equals, it's the leading coefficients, 2 over 1, which is 2. So y equals 2. So there's going to be a horizontal asymptote right there. Okay. And we have some points. See if we can find some more points. Kind of looks like we know what's going to happen to the left of the vertical asymptote. So let's plug in 2. Let's find f of 2 and see what we get. So 2 times 2 minus 1 over 2 minus 1, which is going to be 4 minus 1 over 1, which is going to be 3. Okay, so that is an ordered pair, 2 comma 3. 2, 3. And then maybe we want to put in 4. f of 3. We're just going to go 1 over. 2 times 3 minus 1 over 3 minus 1. And that's going to be 6 minus 1 over 2, which is going to be what? 5 over 2, 2.5. So it's 3 comma 2.5. I'll just use a decimal. Okay, so 1, 2, 3, 2.5. Okay, so we kind of see what's happening there. It looks like it's going to go up this way. You could do more points and find that. And it looks like it's going this way. So it probably is some type of reciprocal function, but we would have to do the long division to see that. And it didn't look like that necessarily from the function that they gave us. Okay, you can find more points, but you could be there all day finding more points. Okay, so you just want to have enough, to know what's going on. It wouldn't have been bad to find a few more points than I found. Okay, there we go. We have a couple more examples of graphing.